Okay, so I'm Zach Christopher, and I'm going to be trying out this physics problem. So what we have here is A says to determine the change in position from t2 to 3.5 seconds. Clearly indicate how the change in position shows up on the velocity graph. Show your work and use units. So to first find the change in position between the dune buggy at 2 seconds and the dune buggy at 3.5 seconds, we first have to find out where the dune buggy is at the starting position, which in this case is 2 seconds. So we look up at the top and it says the dune buggy started at 20 centimeters, and then from our graph we can estimate and say that it looks like it's traveling at a velocity of 30 centimeters per second. So what we do for 2 seconds, so we can do 20 plus 30 plus 30, and then we'll get our starting position of 80 centimeters. And then we look at our velocity graph and we see that it stopped traveling at 30 centimeters per second and is now traveling at a constant velocity of negative 40 centimeters per second for 1.5 seconds. So what we're going to do is then we'll take 80 and we'll subtract 40 centimeters, and then for a half second we'll subtract half of 40, or 20 centimeters, and then that leaves us with 20 centimeters as our end position. And so our change position is negative 60 centimeters, or negative 60 centimeters is our change position from 2 seconds to 3.5 seconds. And you can see it on the graph from here as it drops. It goes all the way from up here at 30 down to negative 40 and then you can see it from the seconds. Yes, okay, so B, determine the change in position from 5 seconds to 6 seconds. So we're going to do the same thing we did before and find our starting position. So after 3.5 seconds on the graph, we see that it goes back up to 0, so that it has a constant velocity of 0, meaning that it's not moving, and the dune buggy is staying at 20 seconds, at 20 centimeters, and so it stays there for 1.5 seconds, and then from 5 to 6 we see it starts moving at a constant velocity of 20 centimeters per second. So what we'll do is we have our starting position of 20 centimeters, and then we're calculating the time for 1 second, so we just simply add 20 centimeters, and our end position is 40 centimeters, and then you can subtract you can subtract our starting position from our end position, and then we have our change in position being 20 centimeters. So now we have to construct a quantitative position time graph for the motion. Assume that at position 20 centimeters, t equals 0. Be sure to accurately number the scale and on the position axis. So I already labeled our position axis. I did it in increments of 20. So if we're at t equals 0, we're starting at 20. We'll put our first point here. At 1 second, it's moved 30. So we'll do 20 to 50. So we're going to put it at the halfway point between 40 and 60 on our position axis. Then we move another 30, and 30 plus 50 is 80. So at 2 seconds, we're at the 80 marker. From there, we see that it starts to decrease at a quick rate of negative 40. So we do 80 minus 40, which would be 40. So at 3 seconds, we put 40, and then at 3.5 seconds, which is this marker right here, we can put you go down 20 more, so now we're only at 20. Yeah, and so from there we then go back down to, so there we're going to flatline from 4 all the way to 5 seconds, from 3.5 to 5, excuse me. And then from there, we're going to start increasing at an increment of 20. So, yeah, that is our graph. So if we connect the points, like so, we have our position time graph for the motion of our dune buggy. So last but not least, we have to draw a motion map for this motion. So each dot is going to represent a second. So we have at 0 seconds, this is our first dot here. I'll label it 0, S for seconds. Then we go after 1 second or all the way up to 50. So I'll put our next dot here and draw an arrow. This is 1 second. Then we're going all the way up to 80. Our second dot here is 2S. Then we're having a turnaround, so we stay here and we go backwards at a speed of -40. So we go 80 all the way back down to here. So that's all the way down to here, and that is 3 seconds. Then, like I said, it's for the half-second interval. We're going to go to 20, and that's 3.5 seconds. And from there, we stop and rest for, ooh, I shouldn't have put that there. We stop and rest for 1.5 seconds. So you just draw this, and then I'll just do a half circle to mark half second. And then we continue to then move backwards up at a speed of 20 centimeters per second. And so we'll draw an arrow here to put here, and that is our 6 second, and that is where we end. So there you go.